Hello and welcome to all students. In this lecture, we learn about permutations and combinations. So there are two parts of this unit. We are starting new unit in this lecture. There are two parts. First part is about permutation and second part is about combination. So in the first part we see about the permutation. Permutation. So basically the permutation means the arrangement. Permutation means arrangement. Okay. So before going to the permutation, we see some principles of addition and multiplication. So let us write the principles. So this topic is based on totally on these two principles. Principles. So first is addition principle. Addition principle. So addition principle is if we have to do two things A and B, and if there are, so I am writing here, see here, if there are m ways, if there are m ways to do thing A, to do A, and if there are n ways to do thing B, then the total number of ways to do thing A or B, then total number of ways to do thing A or B. That is very important. Total number of ways to do thing A or B is given by m plus n. Okay, so this is our addition principle. If we have to do two things, thing A and thing B, and if there are m ways to do thing A, and if there are n ways to do thing B, then the total number of ways to do thing either A or B is given by m plus n. Okay, now second principle, that principle is called as multiplication principle. Okay, so we write the second principle, multiplication principle. Second principle. So if we first of all write multiplication principle. Okay, so that principle says that if there are m ways to do thing A, and if there are n ways to do thing B, then the total number of ways to do thing A and B is m into n, full stop. Okay. So see here, once again, if there are m ways to do thing A and if there are n ways to do thing B, then the total number of ways to do thing A and B, first do A and then do B, the total number of ways are given by the product of m and n, m into n. So these two are the additions and this is a multiplication principle. Okay, after that we see a new concept, and that concept is called as factorial notation, which we are using while solving the problems. Okay, so next new concept is factorial notation. Factorial notation. So in the factorial notation we define, for a positive integer n, for a positive integer n, for a positive integer n, so notation n factorial. So this is the notation for n factorial, and the value of this n factorial is given by n into bracket n minus 1 into bracket n minus 2 into dot dot dot. We decrease the number n by 1 up to 3, 2, 1 and take a product of all these numbers. Okay, so n factorial is nothing but this product. Okay, so for example, so if I take one example, let us take one example. So if I take n is equal to 4, then 4 factorial is nothing but 4 into 3 into 2 into 1, and that product is nothing but 24. Okay, now let us take one more example. So if I take n is equal to now 5, okay, so if I take n is equal to 5, then we write 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Okay, so this product, and this is nothing but, so we decrease this 5 up to 1 and we take a product of all these 5, 4, 3, 2, 1. So it is equal to, the product of all these numbers is 120. Okay, so 120, so 5 factorial is 120. one more example. So let us write the 3 factorial. So if I take n is equal to 3, n is equal to 3, then 3 factorial is nothing but product of 3, 2 and 1, and it is equal to 3 into 2 is 6 and 6 into 1 is 6, so 3 factorial is 6. Okay, so in this way, so this is our factorial notation, and let us go to the our main topic is name of that topic is permutation. Okay, so permutation means the arrangement. Right here, this topic is permutation. Okay, so there are many ways of doing permutation. First is linear permutation, means linear arrangement. Okay, and the second is the circular permutation. Circular permutation, but in this unit we will see about only linear permutation. So permutation means arrangement of objects. Okay, so arrangement, let us take one example. Suppose we have three persons. Suppose we have three persons. Three persons and three chairs. Okay, and we have to arrange, or we have to do a permutation of these three persons on three chairs. Then how many ways are there to do this work? So we arrange means permit. We arrange three persons on three chairs. Okay, so how many ways are there to do this thing? Suppose these are the three chairs: first chair, second chair, and this is our third chair. So in first case, suppose if I arrange first person A here, second person B here, and third person C is here. So this is the one way. This is our first way of doing the arrangement of these three persons on three chairs. Second way is we keep A person as it is and we interchange person C and person B. Okay, now this is our second way. Now third way is we can put B person here and A here, C here, or B person as it is, C person here, A person here. Next way is to do this arrangement is we put C person on this first chair, B person here and A person here, and C person as it is, A person here and B person here. So this is our first way, this is second way, first way, second way, this is our third way to do arrangement, this is fourth way to do arrangement, this is fifth way, and this is sixth way. So there are 6 ways to do the arrangement of 3 persons on 3 chairs. Okay, and these are the different arrangements. No two arrangements are same. So there are how many? 6 different arrangements to arrange 3 persons on 3 chairs. So this is the way. And suppose we have the less number of chairs. In this case, what will happen? Suppose we have 3 persons and 2 chairs only. Then how to do the arrangement, or how many ways are there to arrange these? So how to do the arrangement of these 3 persons on these 2 chairs? Okay, so we arrange we arrange 3 persons on 2 chairs. We arrange 3 persons on 2 chairs in the following way. Okay, so we have 3 persons and only 2 chairs. Okay, so let us go to the draw. Okay, the diagram now. Suppose these are the 2 chairs. Okay, so on these 2 chairs we can put only 2 persons. Suppose if I put A here and B here, so C is left out. Okay, so we write here left person here, so C is left out. So this is one way to do the arrangement of 3 persons on 2 chairs, first way. Now in the second case, we put B person on this chair, A person on this chair, C is left out, second way. In third case, what we will do, we left out B person. Okay, we left out B person and we put C person here and A person here. Third way. In fourth way, we again left out B person and put A person here and C person here. Fourth way. And we left out person A and we put A here. Sorry, so he is left out, therefore we put person B on first chair and person C on the second chair, and in the next case A is left out, C person here and B person here. So these are again 6 ways to do arrangement. To do arrangement of arrangement of 3 persons on 2 chairs. Okay, now let us see the definition. Now let us see the definition of permutation. Okay, so now important definition. Suppose there are n objects. Suppose there are n objects. A permutation of r objects out of n objects. A permutation of a permutation of r objects out of n objects out of n objects. So here r is always greater or equal 0 and less than or equal to n. Is an arrangement of r things. Is an arrangement of r things. Is an arrangement of r things out of n things in a line The total number of permutations is denoted by the total number of permutations is denoted by NPR. So see here how I'm writing this NPR and is given by formula NPR is equal to n into bracket n minus 1 into n minus 2 into dot into n minus r plus 1. Okay, so this is the formula, and if we simplify this formula, so on the right hand side there are r factors. You will observe that how many factors are there? R factors. Okay, r terms, r factors. Okay, so these are, so let us take one example. Can we write one example for 5p4? Means on the right hand side there must be how many factors? There must be r factors, means 4 factors, and these factors are 5, 4, 3, 5, 4, 3, 2. So these are the 4 factors, and the value of this is 120. Okay, 120. So let us take one more example. So 5, sorry, so let us take one more example. Suppose it is, if I want to write, this is 6p2. So 6p2, on the right hand side there must be two factors only. First factor is 6 and second factor is 5, and the value of this 6p2 is 30. 6 into 5 is a 30. This dot means product of 6 and 5. One more example, 8p2. So it is 8 into 7, 56. Okay, then now we write here 4p3. On the right hand side there must be three factors, 4, 3, 2, and the product is 24. Okay, so